In this video, we take a look at our implementation of the SensorEventListener interface, creating our variable SensorEventListener as an object of an anonymous inner class that implements this interface. Now, the interface contains two methods, onSensorChanged, which is the key one that we'll look at in this video, and onAccuracyChanged, which we overrode at the end of this anonymous class as just an empty-bodied method because we don't care in this particular app about when the accuracy of a particular sensor changes. We just care about the changes to the sensor that are being reported. And in this app, that is when the user moves the device around, the accelerometer will report changes to us as sensor events that are passed into the onSensorChanged method. And basically what we want to do is we want to perform a calculation based on those changes that helps us determine whether or not the user moved the device far enough to represent a shake, and therefore we are going to provide them with the opportunity to clear the on-screen image in the app. So in the method onSensorChange, the first thing we do is we use our atomic Boolean variable to determine whether or not there's already a dialog visible on the screen. And again, the reason this is important is while some dialog is already on the screen, the user could accidentally move the device enough to make this app think it's a shake, and we don't want to then display another dialog on the screen, which is the dialog representing whether or not the user should clear the image that's currently drawn on the app. So first we check to make sure there are no dialogues displayed, and if there are none, we then capture from the event object's values array the values that represent the change in the x, y, and z coordinate planes. So in terms of what those x, y, and z values represent, if you take a look at the sensor event documentation, which I already have up on the screen here, you can see that x represents left to right movement of the device, y represents top to bottom movement of the device, and z represents forward and backwards movement of the device. And what we do is we capture all of those values. Then we store in last acceleration whatever the previous value of current acceleration was. Then we go ahead and store a new value for current acceleration in which we just square the x, y, and z values and add them all together. Finally, we go ahead and perform a calculation in which the acceleration is the result of multiplying current acceleration times the quantity current acceleration minus last acceleration. And if that value is greater than our acceleration threshold, that to us represents the fact that the user shook the device, at which point we go ahead and build a dialog that allows the user to choose whether or not to cancel this operation and keep the drawing that's on the screen, or to simply clear what's on the screen. So we create a new alert dialog.builder object. Notice that we're saying doodles.this here instead of just this for the context of the dialog, and that's because we are inside of an anonymous inner class object. So when you refer to this by itself, it would mean the anonymous inner class object. We want the context to be the doodles app object, the activity object I should say. We set our message for the dialog and indicate that it is cancelable, which simply means don't clear the user interface, don't clear the drawing. And then we set up our positive and negative buttons with the erase label and cancel label respectively. For the positive button, if the user says, yes, I do want to erase the screen, then we indicate that the dialog is no longer visible because we're dismissing the dialog at this point, and we tell the doodle view to clear the drawing. If they cancel, we also indicate that the dialog is no longer visible, and we call dialog.cancel to dismiss the dialog. Finally, at the end of the if statement, we say dialog is visible is set to true to indicate that the dialog is now being displayed onto the screen, and we show the dialog.